Hey there guys, welcome back. We are in the word problem section of the playlist for 5.3c, and that objective again is I can solve for quotients when I have a two-digit divisor and a 3 to 4 digit dividend. So right now we're going to review a star released word problem concerning this very T. Now remember, the first thing we're going to do is read through the word problem to make sure that we understand every single word in the word problem. So Tara has a box of 908 beads. EA in this case is the long E sound, E. The A is silent, beads. For making, we have our suffix ing, making bracelets. This C in bracelets is a soft C, because it's in front of an E, bracelets. She wants to put 15 beads on each bracelet she makes. What is the greatest, look here, we have EA again, but in beads, this EA was EEE. Here in the word great, it's AAA, greatest number of bracelets Tara can make with these beads. Okay, so we can pronounce each word correctly and we understand each word. So now let's read for comprehension. Tara has a box of 908 beads for making bracelets. She wants to put 15 beads on each bracelet she makes. What is the greatest number of bracelets Tara can make with these beads? So looking at our problem-solving board, we're going to read, and remember this section is asking, what is the problem asking you to do? So instead of it just be restating the question, we'll go through one more time. Tara has a box of 908 beads for making bracelets. So she's making bracelets with beads. She wants to put 15 beads on each bracelet she makes. What is the greatest number of bracelets Tara can make with these beads? So what is the problem asking you to do? To find the greatest or most amount of bracelets. Find the greatest number of bracelets that can be made. Okay, I think we did that. Now the next part of your problem-solving board is think. And remember, here you are finding facts that are both stated, which are directly in the problem, and unstated, facts that are not necessarily a value, a number value in the problem. For instance, remember guys, the other day we went over a word problem, and it was talking about Mr. Herndon. It was for our warm-up, and Mr. Herndon drank 12 glasses of water a day. How many would he drink in a year? We had 12 glasses of water, but we didn't have 365. 365 days in that word problem was the unstated facts. So let's see what we have here for stated and unstated. So Tara has a box of 908 beads for making bracelets, okay? She wants to put 15 beads on each bracelet she makes. What is the greatest number of bracelets Tara can make with these beads? Two things I want you to notice, guys. I'm constantly going back to my word problem to make sure I understand it. And in this case, I underlined what was stated fact. I don't think in this instance there's any unstated facts. So there's 908 beads in a box, and Tara wants to put 15 beads on each bracelet. Okay, so let's take a few seconds and visualize. I want you guys to start visualizing what exactly a word problem is saying, asking, and so on. So Tara has a box of 908 beads. Here is a box. We're going to pretend there's 908 beads in it. So there's 908 beads in Tara's box. She wants to put 15, so she wants to take out 15. Remember that separating? We're separating 908. So now that we know, based on our modeling, and now that we know we want to separate these 908 beads, and she wants to put 15 on each bracelet, is our 908 our dividend, or is it our divisor? Let's think about that. Let's think about that for a second. She has 908. Remember our array? We had 12. Or remember the crumpets and the coffee cakes? Or remember the tires? We had 12 of them. We have 908 beads. We want to put 15 of these beads on each bracelet, okay? So again, I guess I want to make sure that just because you see the number 908, you don't say, oh, it's the biggest number, so therefore it's the dividend. I want you to understand why it's the dividend. Because we're taking this box of beads and we're separating it. We're separating it. So because we're separating these beads, therefore that's the dividend. Not because it's just the biggest number. Because as you get older in these other grades, your dividend may or may not be the biggest number. Okay, I want y'all to remember that. Put that asterisk in your head about that. So because we're separating this box of beads, the 908 beads, that's why it's the dividend. So just wanted to go through that with you very quickly. So now the next step, we've put down our facts that are stated. There were no unstated facts. Now we're going to solve. So here we go. We have 908 as our dividend. We just discussed that. And our divisor is 15. So now we're going to solve. We can solve through partial quotient, which we already went through in the computation segment. And we also can solve through, of course, standard algorithm. Standard algorithm. Okay, guys. Remember, through partial quotient, you are solving for the entire dividend. Okay? You're not going to go by place value as you would here in the standard algorithm. I saw some of y'all getting that mixed up in some of the activities we were doing in class, and I don't want you to get confused. So when you start drawing this long line for partial quotient, I want you to draw a big line underneath so you know that this whole dividend, you're solving along this whole line, okay? So you know me, I like to go by tens. It's a friendly number for me. So 15 times 10, we're just going to add a 0. That becomes 150. That's 8 We need to regroup. That becomes 5, and that becomes 7. Well, we're still not finished. Shall I go to, I don't know, 20? Let's try 20. I know this would become 15 times 2 is 30. Add a 0, that's 300. Let's check it out. That becomes 8, 5, 4. Y'all want to do it again? Because we can take away 300 from 400. So let's try it. What? Somebody said something. You want to try 30? Because there are 3 15s and 45? Okay, we can try it. 30. 3 times 15 is 45. Add your 0. 450. Okay, you might be on to something. Well, looky here. I believe you're right. So let's add all these up. Zero's place is 0. 1 plus 2 is 3, plus 3 is 60. So we have 60 with a remainder of 8 on this side. Let's see if we get the same thing through standard algorithm. 15 can't go into 9. So we need to move to the next place value so we move to this next place value. Can it go into 90? And yes, it can. It goes in 6 times. 6 times 15 is 90. That's a 0. Bring down your 8. How many times can 15 go into 8? 0. 0 times 15 is 0. Subtract, you get 8. 60, remainder 8. Okay, so the answer is, after we solved, $60, remainder 8. Remember, make sure your place values, the ones is over the ones, the tens is over the tens. But now here's the question. The original question is, find the greatest number of bracelets. Our choices are 61, 70, 60, 68. Well, we have 60 with the remainder of 8. But each bracelet is to have 15 beads on it. So it doesn't take us to 61. So that's out. 70's out because if we don't have 61, there's no way we can make it to 70. That's out. 68, same difference. So our answer is C, 60. Good job. And how do we check? We're going to ask ourselves, is our answer reasonable? I wrote too big. Is our answer reasonable? And the way we can figure that out is round, 908 to the nearest hundreds. That's 900. And easy peasy, 15. How many times can 15 go into 900? And that answer is 60. And we did get that. So good job on your word problem section. I will see you next time. Take care.